Welcome back to task 3. We're making progress. Now we'll be looking at cyclic or cyclic. You can choose however you'd like to pronounce it. I'll stick to cyclic. Right, it says good work. Now cd out of the checksec directory. Next on our itinerary is the cyclic directory. You should find 4 files there. A text of alphabet characters, a flag, an executable, and the code for the executable. If we try to read the flag, we are denied permission. If only somebody else could open it. Right? If you run the ls-tacl command, you'll see that the flag file and the intro to Pwntools are owned by the same user, and that the SUID bit is set for intro to Pwntools. This means that the program will keep its permissions when it executes. Please answer question 1. Which user owns both the flag and intro to Pwntools file? I was working locally, so I had to SSH into the machine just to check the answer. And this is the owner. His name is Dismas. Okay, we have answered question 1. Let's go back up. Where were we? If you view the C code, you may notice the print flag function, which will open the flag with the permissions we need. The issue is that the function does not run in the program, and the program simply calls start then ends. What if we could redirect the execution somehow? In fact, we can. Okay, so let's look at the C code first. So this is the C code. We have our print flag function. As you can see, it is running cat, and then cats out the flag, then exits. But in the main function, it is not called. Like they said, it is not running. The program is vulnerable to a buffer overflow because it uses the gets function. Where's the gets? There's the gets function, right? 24. Take note of that. Because it uses the gets function, which does not check to see if the user input is actually in bounds. In our case, the name variable has 24 bytes allocated. So if we input more than 24 bytes, we can write to other parts of memory. Please answer question 2. Use checksec on intro to Pwntools. What bird themed protection is missing? So based on what we read in the last task, the only bird themed protection is a canary, stack canary. An important part of the memory we can overwrite is the instruction pointer, IP, which is called the EIP on 32-bit machines and RIP on 64-bit machines. Right, so you'll see this a lot in Pwn challenges when you get executables. Usually Windows executables are 32-bit, and so the IP, the instruction pointer, will be called an EIP. And then when you get a Linux executable, it's usually 64 bits, so the IP is the RIP, and we can check this by running file on intro to Pwntools, and as you can see, this is a 32-bit LSB executable. The IP points to the next instruction to be executed. So if we redirect the EIP in our binary to the print flag function, we can print the flag. To control the IP, the first thing we need to do is overflow the stack with the pattern, so we can see the IP. So we can see where the IP is. I've provided the alphabet file as a pattern. Let's fire up GDB. So let's copy this command. Okay, we have GDB running. To run a program in GDB, type R. You will see the program function normally. If you want to add an input from a text file, you use this arrow key. I have no idea what it is called. Right, but that's the syntax. So let's try the syntax and see what it does. Okay, there's a lot of gibberish that it spits out, but it does tell us that we have a segmentation fault. Right, we have caused a segmentation fault, and you may observe that there is an invalid address at 0x4a4a4a4a. invalid address here. If you scroll up, you can see the values at each register. For EIP, it has been overwritten with 0x4A4A4A. Please answer question 3. So our EIP, here it is. It's overwritten with 4A4A4A. Please answer question 3. Let's go to question 3. What ASCII ledger sequence is 4A4A4A? As you can see, it is 4 J's. So we can just copy that, paste it there, submit the answer. Great, now we can see that we can control the EIP. Before we move on, I would like to talk about patterns. The alphabet file was useful here, but it can take time. It can be time consuming to type all of that into a file. Every time you want to test the buffer overflow, and if the buffer is large, the alphabet file might not be big enough. This is where Cyclic Tool comes in. The Cyclic Tool can be used both from the command line and in Python scripts. The command line format is cyclic, then the number, like this. Let's copy that. This will print out a pattern of 100 characters. Please quit GDB by typing quit and answer question 4. What is question 4? What is the output of Cyclic 12? What is the output of Cyclic 12? So let's quit GDB first. That is the output of Cyclic 12. If you have used pattern create from the Metasploit framework, this works in a similar way. We can create a pattern file like this. Let's copy that. And then run the pattern file as input in GDB like we did with the alphabet file. Once again, we have a segmentation fault and the EIP is filled with JAAA. Let's get into GDB first. Actually, we have not made the pattern file. Let's do that here in a new tab. Cyclic 100 output into the pattern file. Exit that. Run our program with the pattern file. And we have a segmentation fault. And our EIP is filled with JAAA. Please answer question 5. Let's go to question 5. What pattern in hex was the EIP overflowed with? So this is the memory address, not the address actually. This is the pattern that overflowed into the EIP register. We can copy that, paste that there. There we go. There we go. We're making progress. Pointing to the flag, we can now begin to develop our exploit. To use Pwntools in a Python script, create a Python file -pwn cyclic.py and then port the Pwntools module at the top of the file, right, like this. We can then use the cyclic function within the Python code. Padding equals cyclic 100. Our padding is the space we need to get to the EIP. So 100 is not the number we need. We need our padding to stop right before JAAA so that we can fill in the EIP with our own input. Luckily, there's a function in Pwntools called cyclic find, which will find this automatically. Please replace the 100 with cyclic find JAA like this. What do we fill the EIP with? For now, to make sure we have the pattern correct, we should fill it with a dummy value, like 0x dead beef. We cannot, of course, simply write 0x dead beef as a string because the computer would interpret this as ASCII, and we need it as raw hex. Pwntools offers an easy way to do this with the P32 function and P64 for 64-bit programs. This is similar to the struct.pack function if you have ever used it. We can add this to our code. EIP equals 0 dead beef. Right, now our entire code should look like this. I'm gonna just copy this with no shame at all. Copy and paste in code. we're supposed to run Python, our exploit, and direct that to attack. So activate my virtual environment, Python, exploit, direct that to attack. Right, now that we have done that, run this new text file as input to intro to Pwntools in GDB and make sure that you get an invalid address at deadbeef. Exit out of that, make that a bit bigger, run with attack. There we go, invalid address 0x deadbeef. I think we can answer this question now. What is the flag? We're not there yet though. Run this new text file. We already did that. The last thing we need to do is find the location of the print flag function. To find the print flag function, type this command into GDB. Let's copy that. Run that, and that is the location of the print flag function. Replace the deadbeef in your code with the location of the print flag function. Once again, we can run Python, our exploit, and direct that to attack. Input the attack file into intro to Pwntools binary in the command line, because GDB will not use the SUID permissions like this. Okay, let's do that. And let's get the flag. So replace that with the address of our print flag function. Quit rather. Clear the screen. Python. Our exploit, direct that to attack. And I have to activate my virtual environment. My bad. Python, exploit, attack. There we go. Then intro to Pwntools with attack, and we get the flag. Alright, one thing I did not note is the fact that if you're testing your stuff locally, if you're running your exploit locally, the flag is not a real flag like it says. So you're gonna have to SSH into the machine, copy over your exploit, and then run it on the box, and you will get your flag. There he is.